Well, here we go. This is the Ed Puzzle video for April 7th to April 11th in the beginning of the fourth quarter. All you got to do is take notes, just like you've done for 3 quarters. And, don't miss it. It's a completion grade. And then you can see here, every assignment we're going to do for the rest of the year is in the spreadsheet. The spreadsheet is available to you on Canvas. You can already know all that we're doing. We're going to do exponents, scientific notation, and then the county has volume being the last few weeks of the quarter. Well, we did some volume, so we're going to finish volume, and then we have the opportunity to do a few more real world things, which are not too hard, like interest, tax tips, sale prices. And I have a special guest here. Hold on. Okay, Mr. Wall is here, but she doesn't want to be. Do you want to be? Okay, she would be. All right. So we are going to talk about. Okay, we're going to talk about. You can have some pencils. Yeah, absolutely. We're going to do properties of exponents, and then rotation rules, and then the last two assignments here are checkpoints. We already did this stuff, so it's just to make sure that you're ready for it on MCAP. You don't get cooked. All right. So let's talk about rules of exponents. Okay. So I'm going to write down some notes and you can take them, rules of exponents, and then we'll do a few examples. So when we have exponents, you already know that like exponents. I know that you already know them because a lot of you guys try to write the slope formula like this, because you know about exponents are tiny numbers, but this is completely wrong, okay? The slope formula has the little numbers at the bottom, okay? But exponents are a thing, like I said, that you know about. 2 to the third power would be not 6, right? It's not 6. It's 2 times 2 times 2, which is 4. 2 times 2 is 4 times 2, which is 8. So exponent is repeated multiplication. We have properties of exponents. Exponents, which we're going to talk about, because you can multiply terms, you can divide terms, you can take terms with an exponent and raise it to another exponent. And those are properties of exponents. So in algebra, we use a variable. I'm going to use a number for a base. So this big number is called the base, right? 2 is the base, and 3 itself is called the exponent, or you could also say power. And we use those two terms interchangeably. Okay, so properties of exponents. Let's say that we have 2 to the 10th power times 2 to the 13th power. If you have the same base, then you can just write the base one time and you can add the exponents. So 2 to the 10th times 2 to the 13th is 2 to the 23rd power. And so we're going to write add exponents. In other words, if we multiply the bases and the same bases, then we're adding the exponents, and that's how we simplify it. So 2 to the 10th times 2 to the 13th is 2 to the 23rd. You can see over here we have the same base and exponents 4 and 2. So this is going to be, we're not trying to actually do it on a calculator. We're just adding the exponents. That's what they want you to do. Express your answer as a single term using exponents. They're looking for you to do 4 plus 2. Okay, so that is one property. We call this with the multiplication rule. And that is right there. Okay, then you add the exponents. Then we have the quotient rule. What do you do for the quotient rule? So let's put the bigger base on top. In our first example, 2 to the 13th divided by 2 to the 10th. In this one, we're going to subtract the exponents. 2 to the 13 minus 10 is 2 to the third. Okay, so in this one, we would subtract exponents. All right, and then there's one more rule, the power to a power rule. Okay, and that would be, let's say, 2 to the 10th, keep our same terms, but now we're going to raise it to the 13th. In this case, that would be 2 to the 130th, because what do? You multiply exponents. Okay, so if we are multiplying terms, we add the exponents. If we are dividing terms, we subtract the exponents. And if we see this thing right here where we're taking a term and raising it, we multiply the exponents. We need one more here. How about the zero? Zero exponent. You might think that 2 to the 0 power is 0. It's not. It's 1. That's the definition. Anything to the 0 power is 1. All right, let's see how far those rules take us into this assignment. This is 725 to the 6th power. That's right. Okay, this is 615 to the 6 plus 6, 12th power. And now here we're going to subtract 228. 3 minus 8 is negative 5. All right, so go for it. Try that one. Now here we do power to a power. Okay, so here was where we are multiplying. 7 times 6 is 42. And by the way, I'm pressing Shift 6, and I'm using that little caret sign to get my exponent real quickly. This is 4 to the 9th. So hopefully these exponents are nice and easy. This one is super easy. It's just multiplying those numbers. Try not to use a calculator. All right, so now let's talk about rotations. We talked a little bit about rotations in the last Edpuzzle video, but I did not make anybody go to 80%. So let's get some rotation rules. So if we rotate, we can rotate by 90. So let's say I rotate a coordinate by 90. What we're going to do is, first of all, I'm going to visualize that. So let's say I take 4, 1, and I rotate it by 90. That would be about there because it's a quarter of a circle. And so I can see that would be negative 1, 4. So if I go 4, 1, and my rotation of 90 is negative 1, 4, what is the difference there? Well, if you remember from reflections when we had the flipping, when we did y equals x, we see that again, the 4 and 1 switch spots, right? So xy changes to yx. But then what else happened? Because we got 4, 1, and then negative 1. Okay, so the 1 not only switched to the x, it also became negative. So the rule is negative yx. Okay? 180, if you go a half circle, you end up right there. That's 180. And what happens there? Let's visualize that. You can kind of see right there. It's negative 4, negative 1. So the rule there is negative x, negative y. So they don't switch spots, but they both change sign. Another multiple of 90 is 270. And what happens there? Now we are 3/4 of a circle, and we're right there at positive 1, but negative 4. So they switch spots like they did with 90, but this time the x is negative. So it's like that. So those are the three rules of rotations, multiples of 90. And this is for counterclockwise. So this is 90 degrees counterclockwise. And it's all, so I'm going to write counterclockwise. I'm going to put CC. Clockwise is the other way. So this is clockwise. If you look at the clock and the way that the second hand is moving is clockwise. So I'm going to write that down here. So this is clockwise, which in rotations is negative, and counterclockwise is the other way. And that is positive. Okay, so 90 degrees counterclockwise is the same as if it had said 270 degrees clockwise. 180, you can go halfway this way or that way, you get to the same spot. So that one is only 180, you know, counterclockwise and clockwise is the same. 270 degrees counterclockwise is the same as 90 degrees clockwise. All right, I'm gonna write those down because I always forget those. If you didn't write them down, I don't know why. But I always forget the Y and the 90 and the 270. So I'm just writing them down there. 180 is easy for me to remember. So now we're going to see how far that takes us into this assignment. 10, 1, and we're rotating 90 degrees. So I know that 10, 1. Okay, 10, 1, and I'm going 90 degrees counterclockwise. So I know they're switching spots and the Y becomes negative. So I'm going to graph negative 110. Negative 110 right up there. That is it. That's it. Oh, I told you. All right, 90 degrees clockwise. So now when I see that, that means it's the same as, so I'm going to use my rule for 270 degrees counterclockwise because they're the same. So 4, negative 4. Okay. 4, negative 4, and we're going, says 90 degrees clockwise, but I know that's 270. We could do either one, but in any case, that's the Y negative X, right? Y negative X. So they switch spots and the X value changes sign. So this is the X value. It becomes the Y value. This is the Y value. It becomes the X value. And this one changed sign because of my X value changed sign. So negative 4, negative 4. You can see that this one will take you some practice because there's lots of switchings and flippings and you got to practice to get it right. All right, let's do one more here. 0, negative 2, 180, and 180 is the easy one because clockwise and counterclockwise is the same, and there's no flipping. They just both change their sign. So that means 0 becomes negative 0, which is the same as 0, and negative 2 becomes positive 2. So 0, negative 2 goes to 0, 2. Guys, if I can do it, you can. And now this one, you just rotate each point. So this one just gives you even more practice. You're going to do what we just did for all 4 points, and then you'll have a shape that is like turned, so this, it's a square, so it's not going to look, but if it was a triangle or something, you could really tell that it's rotated. All right, so go for it. Try that one, traffic light problems and everything, and, have fun. Now this is construct and interpret linear functions, which we did this week. And so I just want you to do it again next, with this group of assignments because our MCAP, so here we are, and then we'll have one more week, and then MCAP. So you got to make sure that you have your linear functions ready to go, and then solve linear equations. I need to talk to you about this one because it's been 3 quarters and some of you are still Googling your answers. So let's stand by for a message from Coach Field. All right, just a quick minute here. Coach Field, character that I made a couple years ago to help students when they think about doing something they shouldn't do, and just to encourage you to do your best. So let's just listen to hear what he has to say about Googling your answers.
Hey, this is Coach Mr. Field here. I just want to tell you some helpful information. Turn off the Google. Turn it off. Cut it off. Get it out of the classroom. It ain't belong in the math classroom. You don't Google things in math. You learn math. You got it? You can't learn math through Google either. Ain't got nothing to tell you. The only thing you need to Google is those file cabinets in your mind. That's where that information's got to be. It can't be on some outside resource in some server in Oklahoma. You got to get that information in here in between the ears. You got it? So you're going to memorize your multiplication tables. You're going to memorize your formulas. You don't need a formula sheet. Someone gives you a formula sheet. You say, thank you, I don't need that. I got it in my mind. All right? That's what you got to do if you want to learn math. If you want to be any good at it, you don't want to be counting the change incorrect at the cash register and they need a machine to give you to get the machine change. No, you don't need that because you're going to turn the Google off. Cut it off. All right, let's go do some math.
All right, thank you, Coach Field. All right, so that's important because some people are still Googling their answers and not learning anything. Okay, so I'm not muted. So I don't know why you would do that. Then you don't learn anything, and then you can't do anything. And then those same people can sometimes email me about their grade and say, how can I get a better grade? And I say, well, you're Googling things, so you really can't unless you put in the work now. That should make sense to you. But it's a brand new quarter, it's a brand new day, and we all have a chance to put in the hard work so that when you get older and this math keeps building on itself, you're ready. So let's talk about this one and a couple more. Find values for P and Q so that X equals 2 is the only solution to the equation. Wow. All right. So then if X equals 2, and I've never done this before, but I'm going to substitute. I mean, this particular problem, I'm going to substitute 2 in. I don't need to write X. Okay. So that's the first step. 2. Notice I did not Google it. And then 5, 2 minus Q. Okay. So now I have 2P, now I'm just simplifying, plus 6 equals, and then I'm going to distribute 10 minus 5Q. Okay. So I'm looking at this here. I'm gonna pause it so I can think about it. See, I really gotta think about this one, but I'm not gonna Google it. All right, I had an idea. We're gonna try it out. I've not Googled anything, so it may work, it may not. But as you can see, my first thought was, okay, plug in X, substitute in 2 for X. But now I have 2 variables, and now I'm thinking, how do I do that? So let me just give you some notes here real quick. If we have, let's do 1 solution, no solution, and infinite solution. You remember that? Okay, so one solution would be 2x plus 1 equals x plus 3 because my coefficients are different. No solution would be 2x plus 1 equals 2x plus 3 because my coefficients are the same, but my constant terms are different. Infinite solutions would be when you have the same thing on both sides. So this is what's going through my mind right now. And I need an example of one solution, and I need the solution to be 2. Well, guess what? There's lots of equations where the solution is 2. And so we should be able to put different answers. So I'm going to take and I'm going to say, let's make P equal to 1 and see if we can do it. Then we just got to figure out what Q is. The reason I want P to equal 1 because that's easy. Okay. And so now I am going to go ahead and write X plus 6 equals, and I'm going to distribute 5x minus 5q. And then I'm going to put my variables on my left side. So now I'm just using inverse operations. And that's negative 4x plus 6 equals negative 5q. Again, I'm just using everything I know to try to figure this one out. Okay, so now I know that x has to equal 2. So now I can see that if I substitute in 2, now it's going to make sense to me. So I made P equal to 1. And now I'm comfortable saying, all right, let me put in x is 2. X has got to be 2, right? So let's put in 2. All right, so that's negative 8 plus 6, which is equal to negative 5q. And then that's negative 2 equals a negative 5q. And now I just thought to myself, wait a minute, do these have to be integers? They don't say that. Okay, so that's good. Now divide, so let me write that again. Negative 2 equals negative 5q, and then divide both sides. Divide both sides. And q equals 2 over 5. So let's see if that works. Well, then we could even check it, right? So now I'm saying 2/5, right? So P equal to 1 and Q equal to 2/5. It should make X equal to 2. So that would mean X plus 6 equals 5x minus 2/5. And we should get X equal to 2. So let's just solve that to check. So I'm going to distribute 5x. 5 times 2/5 is 2 because the denominators would cancel. X plus 6. Now, get nervous here. Oh, I think it's going to work out. Okay, that's negative 4x plus 6 equals negative 2 minus 6 on both sides. Negative 4x equals negative 8. Divide x equals negative 8 divided by negative 4 is 2. Look at that. See, I did not need to Google it. I got it, and you can get it too. I just took everything I know, everything I knew, and I did not give up. Because it got to be a positive example to you guys. And look, it was terrific. Okay. So that is the kind of thinking that you're going to have to do in the MCAP. You're going to just have to use everything you know and try it. And if you take this opportunity to do that, then you won't feel defeated when you get to the MCAP. Okay, which you will take on that Monday and Tuesday of the last week in April. And that's it. That's all we're going to do right now. So I will see you in class.